Okay, so I'm going to be talking about the NoSQL landscape, or kind of an introduction to NoSQL. This is kind of what I want to get across. Kind of what I want to get across to you guys. We all live in the RDBMS world, the Oracles, the Postgres's, MySQL, and all that kind of stuff. And this is quite a bit of a different world. Takes a little bit of a different way to think about it. And so I'm going to do a little bit of a progression from SQL into NoSQL and kind of some of the stuff that works in that area. But my goal is to kind of provide at least a high-level education. And it's a really broad subject. There's a lot of products, a lot of things to understand and know. More than happy to try and answer questions. Certainly I'll be available afterwards for a while. We can, if you guys want to stick around and talk. I'm working for a company right now called Yuhu.com. I've been working for Overstock.com for about 3 years previous to this. And I've got a blog here, nosqltips.blogspot.com, and a Twitter feed as well. And I have some contact cards if you guys want to get a hold of me at some other time. So this is a little bit of what we're going to talk about. We're going to talk about what NoSQL is, kind of landscape, some of the products that are in there, some of the a little bit of new vocabulary that we're going to introduce as part of all this. We're going to go through some comparisons on the world that we know versus this world that don't want to say that we don't know, but it's a little bit of a new world. And then we're going to go into a little bit of detail into kind of each type or each subtype and talk about what makes them unique and why would you actually be interested in using them at all. And then we've got some Q&A and we'll go afterwards. So NoSQL does not mean NoSQL. Actually, it really has very little to do with SQL at all. It's better to think of a NoSQL database as a non-relational database, right? As a matter of fact, NoSQL and SQL go very well together. A lot of companies are not using just one product or another product or one type or another type. They're often combining them using RDBMSs for what they're really good at, especially transaction processing, and using non-SQL derivatives for the things that they can be really good at. This might be a little bit hard to see with the lighting, but over here on the left, I've kind of lumped a lot of the products that we're used to right now with RDBMSs, OLAP databases, object relational databases. It's slightly unfair, but I'm just going to call those row store databases. What I'm really more interested in talking about is on your right-hand side here, which are some of the breakdown of some of the NoSQL databases or data stores. And this breakdown is kind of what I've done on my own, or what I've kind of decided is interesting to me. You'll see these broken down in different ways, but my main kind of criteria were, what's the scalability model, what's the data model, and what's the kind of underlying storage model for these products, and that's how I used it to divide them up. So we basically have a column store database, which is going to be really similar, which is going to be the most similar to the row store, or the RDBMSs. Then you have basically a document store, or what's a key value. Basically, it's a big hash, right? That's how we treat it. And then memory stores are the third one. A lot of times they're lumped together because the data model is essentially simple, both key value stores. But I separate them out because the storage model and scalability model tend to be quite a bit different. And then the last category I have here are graph databases or triple stores, as they're called. A little bit of a timeline. We start around the 1970 mark here and finished out at least as of last year. So the black ones are more of the row stores. The blue ones are going to be more of the NoSQL types. You can see RDBMSs tend to be quite a bit older. We've got Oracle over here. Started in 1977. I think the first release is in 79, and they've kind of dominated a lot since then. But in the 2000s here, we see a lot of new products being developed around NoSQL style technology. So there's a lot of products, a lot of interest, a lot of development going on. So some vocabulary, some things we're going to talk about. One of the first things is CAP theorem. We'll go into some detail about that, but it has to do with consistency, partitioning, and availability of your database, your data store. ACID, we should be all pretty familiar with that. Atomic, consistent, isolated, and durable. Those are the kind of things that we like, especially in the transactional world. We want to be able to write our data and be certain that it did exactly what we want to. Kind of a polar opposite of this is a little bit derived in the NoSQL world. It's called a base transaction. Basically available, soft state, and eventual consistency. We'll get into that just a little bit more. RDF, which is really important with your graph stores, resource description framework. It comes out of the W3C Semantic Web Committee or community. So it has to do with describing relationships between data points. Sharding is just a term for partitioning or distributing your data. And then another term that comes up is web scale, which basically translates to really, 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 really big. You know, you're operating on hundreds of millions or billions of rows of data, millions or tens or hundreds of millions of users, and how do you deal with that? How do you process that data and make it useful? So this is kind of a basic diagram talking about CAP theorem. And CAP theorem basically states that you can have any two of these, consistency, availability, or partition tolerance, but not all three at the same time, right? So consistency has to do with the view that the clients see of the data in the presence of any kind of updates or inserts or deletes or something like that. So do all your clients see a consistent view of the data? Availability and partition tolerance are really closely related. They're basically have to do with different types of failure modes. Can the data survive different failure modes? So in the RDBMS world, we basically have consistency and availability, and we give up a bit on partition tolerance. It means that a lot of the RDBMSs are difficult or can be more difficult to scale in a partition sense, meaning can I get 10 boxes in my Oracle cluster to work well together? And the answer for that actually is you can, but it can be very expensive. But it tends to be harder to do. Most of the NoSQL stores will tend to live in the partition tolerance and availability world and give up a little bit on the consistency model. And if you think about it, if you've got, say, 100 nodes in a cluster, it takes some time for information to propagate throughout that cluster. That's where consistency comes in. And a lot of times you can kind of tune that consistency depending on what your needs really are. A little bit more detail about this particular theorem or how to use it. So there's a formula, actually not really a formula, but some variables that are used, N, R, and W. So N is the number of data copies that you want to store in your cluster. So say you've got 100 nodes in your cluster. For every piece of data that you want to write, or you write to that system, you want to keep N number of copies. Usually that number is 3. Read quorum and write quorum have to do with how many copies of that data did I read or write. Do I need to agree with each other before I'm going to call that good, right? So you could say, I want 3 copies of my data to be written to disk, but when I read it back, I only want to make sure at least 2 of those copies agree. If the third one doesn't agree, then I'm okay with that. So hard consistency is our RDBMSs. Soft consistency, you don't really have a lot of guarantees on your reads and your writes, and there's some systems that can tolerate that just fine. Eventual consistency is usually what we're looking at in the NoSQL world. This is some kind of a little bit more on the formulas. I'm going to kind of go through. I'm going to skip a lot of this. It's not terribly interesting, but if you want to have strong consistency on your reads and your writes, which is RDBMSs, basically your read quorum and your write quorum are the same as the number of copies. So if I have 3 copies of my data, I want to make sure when I write that all 3 of those copies agree, and when I read, all 3 of those copies agree. When I'm doing that